Okay, here we are in Chapter 13, Exponential and Logarithmic Functions. And here in 13.3, we're going to talk about logarithm properties. So there's going to be specific properties we're going to look at here. So we have three of them on this page. The first one is called the product property of logarithms. So a logarithm of a product is the sum of the logarithms. So if we have the logarithm of m times n, so logarithm of a product, what we can do is we can split that into the log of the m plus the log of the n. And it doesn't matter what our base is, it's going to stay the same on all of them, but it's going to be the key is we're splitting that apart into two separate logs. And again, here a is the base, has to be greater than 0, can't be equal to 1, and our m and n can not be 0 either, so they have to be greater than 0. Otherwise, it's going to give us a negative value here, and so that's not possible taking logs. Okay. Now we also have a quotient property, so instead of multiplication, we have a division or a quotient of two logs. What happens is when we take the quotient of m divided by n and take the log of that, we can split that into the log of the numerator minus the log of the denominator. And so that's what we get here. We have the log of the numerator minus the log of the denominator. Same rules apply. A is greater than 0, cannot be equal to 1, and m and n have to be greater than 0. Okay, and n for sure cannot be equal to 0 because you can't divide by 0 here. And then our last one here is the power property of logs. This one's very useful. And so basically a logarithm to a power is the product of that power and a logarithm. So basically we're saying, okay, we're taking log base a of m raised to the p. And what we do is then we bring that p down front here, and it's p times the log base a of m. And so this is going to simplify a lot of problems for you by bringing that p down in front. Sometimes we go the other way and we condense it, and so then we'd bring it back up here and have it to the power p, but a lot of times we want it down in front to simplify things. And again, here a is the base, has to be greater than 0, not equal to 1, and in this case m has to be greater than 0. Since we don't have an m, we just have the, or don't have an n, we just have the m. It has to be greater than 0. And then we have a nice one, change of base formula. So if you don't have a calculator that will actually take log base 243, you have 6, then what we have is this nice formula. And what we can do is we can rewrite logs in different bases. So if we have a, b, m all greater than 0, and a and b can't be equal to 1, then what we have is this log base a of m. What we can do is if we can't do that in our calculator, then we're going to take the log of m divided by log of a, and notice we just said log, and what that means is we can use the base 10, as in the case when you have nothing here, that's base 10, or we can convert it to the natural log instead of the common log and use ln of m over ln of a. And remember, this is log base e of m and log base e of a. Okay, but ln is what's on your calculator, and you can do those, or log on your calculator is the one you can do. This one, log of m over log of a. Okay, so it's really nice, and I don't know why, but I majority of the time switch it to ln just because it's less letters to write, and so instead of writing log, I just put ln, and so you'll notice I do that probably. Other properties of logarithms we have, and so again, a and m both greater than 0, a cannot equal 1. Then we have log base a of 1 is equal to 0. Now remember, a to the 0 is equal to 1, so that one makes sense. Now here, log base a of a is equal to 1. Well, if we go back to our properties, we take a to the 1, that's equal to basically a, because a to the 1 is just a, and that equals a, so that makes sense. Now here we're raising a to the log base a of m, and that's just going to be m. And so that one is just if you have some base and it's taking that here, raising it to the log base a, same base again, of m, we just get m as our answer. Now this one, remember, log base a of a to the r, well, we're going to bring that r out in front, so it's going to be r times log base a of a. Well, log base a of a we know is 1, and so that just is r here. Okay, so that's another one where it's kind of a couple of them split together and makes it simple. So those are 4 that we need to kind of remember that's going to help make our lives a lot easier. And the key one, I think, is that one is not one used often, so you'll have to remember this one. The rest of these we can get by converting to exponentials and using the power property and taking that down. So that only that one is one you'll have to kind of memorize because it's not one you'll use very often. All right, so what we're going to do here is we're going to write the expressions as a logarithm of a single expression. So what we're going to do is we're going to take, in this case, 2, and we want to put it into 1. And here we have 1, 2, 3, and we're going to put it into 1. And so that's really what we're going to do. Now to do this, again, you have to have the same base. If you don't have the same base, you can't do these. So what do we have? And remember, when we had the product property, if we go back to that, if we had log base a of m times n, then it was just log base a of m plus log base a of n. And so what we're doing is we're going the opposite direction now. And so we're taking whatever m is and multiplying that by n, and we're going to put it into that single log. And so that's what we're doing now. And so that's what we have here. We have an addition, and so we're going to convert this into log base a of 6 times x. Okay, and that would be all we have to do because we just have that one thing. Now what about this one? Well, here we have this little anomaly out here. Okay, we have that 2. Well, what do we know about this? Well, if we wanted to, what we could say was that was going to be taken care of by this little number here, because if we take anything times 1, we get that value out. So 2 times 1 is 2. So this is the same as 1. And so what we're going to do is we're going to say, okay, well, we're going to say multiply this by log, well, what's our base here? A of A, because log base A of A is 1. 2 times that is just going to be 1, or 1 times 2, or 2. Okay, so now what we have to do is we have to, again, we're going to try to get this all into 1. We have all of these numbers out in front, so we're going to have to reverse the power property, and we're going to have to take that number and we're going to put it back up here as a power. We're going to take the 2 and we're going to put it back up here as a power. And guess what? That 2 now comes back over here as a power as well. Okay, and so let's rewrite it just with the powers in place. Log base a of 2x plus 1 cubed minus log base a of 2x minus 1 squared plus log base a of a squared. Okay, now we have all the same bases. So now what we see is, well, we're just going to take and convert this into log base a of something. Now this one minus this one means we're going to put this one on top. So 2x plus 1 cubed. Now when we minus, that means that one's going to be on the bottom one. So that's going to be 2x minus 1 squared. Now we have another plus, and so we're going to put a squared on top. Okay, and so now we've converted those 3 into a single one, where we had the first one is from here, a squared is from the last part, and the 2x minus 1 squared is from that middle term because we had the minus there. So the minus gave us the division, and then the plus, and that one you have to think of as it's adding it, is going to be all in the numerator. Okay, and so that's how we're going to do that. Well, what about this one? Well, we have log a, log base a, log base a, and so the first thing I need to do is I need to bring that up here and put a 6 here instead. Okay, and so now this one really looks like this one, so maybe this one probably should have been first, because now we have log base a of, well, we have m over, now this one is n, and then we have k to the 6 is plus, so then k to the 6th, and that's all we have. Now if we wanted to write it in, alphabetical order, then we put k to the 6th m over n, but it really doesn't matter because I'm just going in the order they had it in the kind of expression here, the m first, then the k to the 6th last. All right, what about the next one? Well, here we have log 8, log base 8, log base 8. No numbers in front, so there's no powers. And so we also have all addition. So it's just going to be log base 8 of the first thing, 3. and then it's going to be, let's put all that in parentheses, then times x cubed minus 2 times 2, and then in parentheses. Well, this is just a product of three things, and so can we do that? Well, 3 times 2 is 6, and so that's going to be 6 times x cubed minus 2. Well, can we distribute here? Well, yeah, we can take 6 times that and 6 times that, so it simplifies, and so that gives us log base 8 of 6x cubed, and then minus 12. Okay. Now, if we were starting with this, we could decompose it into that if we had to. We would just have to factor that into the all possible factors. And when we did, we'd have a 2 times a 3 times an x cubed minus 2, and then we would just have to separate them out with the pluses in between them. So it is possible going both directions. We're just first starting and going and plugging everything back into the one way first. All right, so now what we're going to do is we're going to go the other way. So now we have a log of in one term, and we want to split it into the sum and or difference of logarithms, depending on how many there are. So if there's more of them, then we'd split it into more. If there's less, we'd split it into less. So this one's going to have 2, this one's going to have 3, and so on. And then it says express the powers as a factor. So that means if we had, the log of base 8 of x to the 4th, we're going to write that as 4 log base 8 of x. So we're going to split it like that. Okay. So the first one, well, we have a quotient, and so that means we're going to have a difference. And so we're going to have log base 2 of x squared minus log base 2 of y to the 6th. So that's our first term. Now we have to remember express powers as factors. So we're going to bring that down here, and we're going to bring that down here. So that's going to give us 2 log base 2 of x minus, now there's going to be a 6 log base 2 of y. And that would be what our final answer is. Again, that's a 2 there. Okay. All right, so now this time we're going to have 3 terms when we get done. And so we're going to split this into, well, it's going to be log base b of x. And then these two are multiplied, so it's going to be plus log base b of y to the 5th. And then we have a quotient, and so it's going to be minus log base b of z to the 7th. Now, express powers as factors, so that means we're going to have to bring that down here, and we're going to have to bring that down there. And so we get log base b of x plus, and then it's a 5 log base b of y minus, and then that's 7 log base b of z. Okay, and so that would be how we would split this one up, and that'd be all we have to do. All right, what do we have here? Well, on this one, it looks like we're going to have a couple things that we could do here. First, let's go ahead and break it apart. That's a quotient, so that's going to give us log base 4 of 64 minus log base 4 of the square root of x minus 1. All right. So log base 4 of 64. Well, this one you kind of have to think about back to when we had log base 4 of 64 equals x. Well, 4 to the x equals 64 so we're going to take 4 to the power x equals 64. Now, is there anything we can take here and get to the 64? Well, x here is equal to 3. So this term actually turns out to be just 3. Now remember that one time we had a 2 way on the end on the problem here, and we knew then that was log base a of a, and so we had to add that on because it was 2 times 1. Well, that's kind of what we had to do here, because this is really 3 of log base 4 of 4, and so that's what we have. So we're going to convert this to just 3. Now, what about this square root of x minus 1? What do we know about square roots? Well, x minus 1 to the 1/2 is really what that square root sign means. It means take it to the 1/2 power. And when we do that, that shows that it's a power, so we actually have to bring it down front. So that's going to be minus 1/2 log base 4 of x minus 1. And so now we're into the final step there. We've got it all written out in the proper form. We've got the powers down in front. We've simplified if possible. And this one, we knew that there was no x's or any variables that we had to take care of. And so we could rewrite that as just strictly a number. All right, what about the next one? Well, the next one is kind of similar to this one, except we don't have the quotient. So that's just going to be log base b of x plus log base b of z to the third. Now that power, we have to bring it down front. So that gives us log base b of x plus 3 log base b of z. And that's as far as we have to go there. We don't have to do any more simplification because there's nothing we can actually simplify. All right, so here we want to use the change of base formula. So it's because if you don't have a calculator that can actually do that, then we have to do this change of base formula. And remember, we can use either the log base 10 or ln to do this. And remember, I said I usually use ln just because it's easier to write out. So what we're going to do, it's going to be the ln of the value, 23, divided by the ln of the base, which is 3. And so now we plug that into our calculator and we get, so let's clear that, we're going to get the ln of 23 divided by ln of 3, and we get 2.8540. That doesn't round up, so that I think it said 4 decimals. And to kind of prove to you that it doesn't matter if we use ln or log, we'll do the same thing here. And we get the same value. So again, it doesn't matter if you use natural or common logs, you get the same value. And so let's go back here, and that was 2.8540. Okay. Well, what about this one? Well, we get the ln of 57.8 divided by the ln of 19. And here we're going to have, and I'm just going to write them out, and then we're going to go over to the calculator and get our values. So that's going to be the ln of 20 over the ln of 0.4. Okay, so let's go get our values. So our first one was, well, let's just do, I guess number 2 went to the right, so we'll do it first. So that was the ln of 20 divided by the ln of 0.4. So if we write that down, it's negative 32694. The 1 doesn't round up, so it goes to the 4. And then the other one was the ln of 57.8 divided by the ln of 19. And so we get 1.3778. The 4 doesn't round up, and so those are going to be our values there. And so that one was on the right, that was a negative 3.2694 because it didn't round up. And this one was 1.3778. Okay. And again, you could use ln or log and they give you the same values there. We saw that when we did this one here. So we'll go ahead and write it out as both of them because we both got the same values. All right. What about the next ones? Well, here we're supposed to evaluate the logs. And now these are kind of going back to those 4 special cases where I said, you know, some of them are going to be easy. Some of them you're going to actually have to memorize what the values are. So remember, if we set this equal to x, that says 23 to the x equals 23. And 23 here, it's assumed that's 1, so x equals 1. And so that's what the value is. So here, this is equal to 1. Now the next one is over here, I guess. And so we have log base 11 to the 11. Now remember, that's just one of those powers. We just have to bring that down. So that's 0.394 log base square root 11 of square root of 11. And when you have that and that, we just saw that that's equal to 1. So that's equal just to 0.394 because this is equal to 1. Okay. So this is the one that I said you had to remember the trick. So this is the same as the base. And when you have that value raised to the log base, same thing, of square root of 5, that's just going to give us the square root of 5. So there's no real calculations. It was just we had a to the log a of m, and that was equal to m. And so that was just one we had to memorize. All right, what about the next one? Okay, well, let's just work it and see what we get. So we get 1/3 to the x is equal to 1. Well, what values of x are going to work here? Well, the only value of x that's going to work is when x is equal to 0, because anything to the 0 is 1, and that's the only way we're going to get 1/3 to there. And so this value is just our 0 in this case. So that's all I have for 13.3.